let's go through question 4 of the 2022 O-Level A Math Paper 2. The diagram shows a closed food container designed in the shape of a cuboid. The rectangular base has dimensions of x cm and 3x cm. The height of the container is h cm. The volume of the container is 2000 cubic centimeters. Show that the total surface area of the 6 faces of the container is 6x squared plus 16,000 over 3x. All right, so to get this expression, we first need to find an expression to represent the total surface area, right? Even if it's not in this form yet, we just have to find our initial expression first, and then we'll convert later on. Okay, so basically for this question, you can see that the final surface area expression does not have any h in it. Okay, whereas we have a height here that is h cm. So that is your clue that your h has to first be represented by x. Okay, you have to represent h in terms of x. So let's do that. So we use the volume of the container to help us. So because the volume of the container is 2000, we know that the length times the breadth times the height will give us 2000. Okay, so 3x squared h equals to 2000. So h is equal to 2000 over 3x squared. The total surface area, okay, let's find that. So the total surface area is made up of 3 pairs of faces. Okay, the first pair is the base, the bottom part. How do we get that? It's 3x times x, right? So that will be 3x squared. Okay. The face on the right is x times h, so it's xh. And the top part is it's the same as the bottom, so that's still 3x squared. But the remaining side is the front and back. Okay, so front and back would just be 3x times h. So 3xh. Okay, so these are your 3 faces, and each of them has a corresponding similar face. Okay, it's exactly the same, so they come in pairs. So you can just represent the total surface area as 2 times the sum of these 3 faces, right? So there'll be 3x squared plus xh plus 3xh. And we can simplify this first into 4xh. Okay, and then at this point, we expand. And the last thing we do is to sub in the expression for h. And when we simplify that, we'll get the final expression that they want. Okay, so that's how you do part A. Okay, let's move on to part B. Given that x can vary, find the value of x for which the total surface area is stationary. For the total surface area to be stationary, okay, this is when you recall the concept of dy dx. So basically, because we want the surface area A to be stationary, dA dx is equal to 0. That's when your stationary point occurs. Okay, so first we need to find dA dx. We know that our original expression, okay, so recall that A area is 6x squared plus 16,000 over 3x. Okay, so dA dx, you just differentiate that. You bring down the 2, multiply it by the 6 to get 12, and your power reduces by 1. Okay, okay, and this 16,000 over 3x, right? This part is the same as 16,000 over 3 times x to the power of -1. X to the power of -1 is 1 over x. Okay, so it's the same as 16,000 over 3x. So why am I representing it like this? It's to show you if we, again, like bring down the power to differentiate. When we bring down the power, you are bringing down -1 Okay, so that's where I'm getting this -1 from, minus. And then you just copy over the 16,000 over 3. Okay, but the x is now to the power of -2 because you have to reduce the power by 1. And x to the power of -2 is just 1 over x squared. So basically your x squared will be in the denominator. Okay, so that's how you differentiate it. So when dA dx equals to 0, that expression will also be equal to 0. Okay, we combine the two fractions. We combine the second fraction with the 2 of x. So we need a common denominator, which is 3x squared. So I'll multiply 12x by 3x squared. Okay, and since the fraction is equal to 0, we can conclude that the numerator will also be equal to 0, right? So we can just simplify the question into this. Okay, so x, we can solve for x, which will be the cube root of 16,000 over 36. Okay, so this is to 5SF, but our final answer, we want it to be to 3SF. So it's 7.63. Okay, part C, determine whether this value of x gives a maximum or minimum value for the total surface area of the container. Okay, so recall when, after you've used your dy dx, right, to get the stationary point, to determine the nature of the stationary point, you use d2y dx squared. So you have to, basically in this context, you have to differentiate your dA dx one more time with respect to x. Okay, so recall that your dA dx was 12x minus 16,000 over 3x squared. So d2a dx squared is equal to 12, okay, minus, okay, let's again convert this. So I'll do the long method. I'll show you the, okay, so this 16,000 over 3x squared, it's the same as 16,000 over 3 times x to the power of -2, right? Okay, so when you bring when you bring the -2 from the power down, okay, you'll get -2 times the already existing negative here. So you'll actually get positive. Okay, positive 2 times the 16,000 over 3, and now it's x to the power of -3. Okay, and if you simplify that, it will be 12 plus 2 times 16,000 is 32,000 over 3, and x to the power of -3 is 1 over x cubed. Okay, so in case you are confused about how I got this is the step-by-step. Okay, so this is your d2a dx squared. Recall your x was 7.6314, okay? So what you can do, there are two ways you can continue from this point. Either is fine. You can just sub in x equals to 7.6314. Okay, so when x equals to 7.6314, d2a dx squared is equal to 12 plus. So you really just sub in 7.6314 and sub in the 5SF answer always. It's power of 3. And you can see this value, you can put it in into your calculator, but even before you do that, you can see that this value will definitely be a positive number, right? Okay, just from the expression itself. So even before you sub it in, okay, the alternative method is to just use this form. Since you know x is greater than 0, okay, the alternative method is here. So I'll just write it. So you can just continue and say, since x is greater than 0, d2a dx squared is greater than 0. You don't even have to show the substitution. But even if you do, that's still the same. You can see, you can show from here that d2a dx squared is greater than 0. Okay, remember when your d2a dx squared is greater than 0, is it a minimum or maximum point? Okay, so recall it's a minimum point, okay, if your d2y dx squared is greater than 0. So therefore, the surface area A is a minimum. Okay, so recall when d2y dx squared is greater than 0, you have a minimum point. When d2y dx squared is less than 0, you have a maximum point. Okay, so this is the solution to this question.